7.1 or 7.4 part 1 redo. So properties of similar triangles, we will after today be able to identify similar triangles and then calculate any missing side lengths and angle measures of similar polygons. So first we have to identify what similar or define what similar polygons are. So similar polygons are polygons that have the same shape, not necessarily the same size. So remember, a similar polygon is a shape that's dilated. It's made bigger or smaller. But all of the sides are made bigger or smaller by the same scale factor. If two polygons are similar, all of the angles are congruent, so which means they are the same. The measures of the corresponding sides are proportional. So they're not necessarily going to be the same, but they're going to be proportional. So this side here to this side, so I have my two pink sides here, they will be proportional. Not necessarily the same size, but proportional. All of the angles here, I have one arc, and the X have one arc, so that means that A and X are equal. Just because one of them is equal doesn't mean that they're all going to be equal. So you have to check them all. So this one has 3, this one has 3, so they are equal or congruent. So it has all congruent angles to one another. And then side length AB and XY are the proportion or the ratio of the two is equal to the ratio of the other two. So the pink, and then the one I didn't write, but AC and XY. Okay, then to find out if they are proportional, or similar, you need to find the ratio of the two sides. So you want to, first we're figuring out if these two polygons or two rectangles are similar. And they're similar if they have congruent angles, which I have a 90 degree, 90 degree, 90, 90. So this one and this one are equal. It doesn't mean that all of them are the same. They don't all have to have the same 90 degree angle. That's just a coincidence. Well, and it's a rectangle, but it means that H and M have to be the same. H and M are both 90 degrees, so they're the same. J and N, J and N. So corresponding angles are congruent, and that's true. Then you want to go, and here we could say the shorter sides. So 3 and the shorter side of this one would be 6. So 3 to 6 reduces down to 1/2. And then the longer side, 7 to 10, reduces down to 7/10. And those two are not equal, so therefore it's not similar. So the ratios of the corresponding sides are not equal, so it's not similar. It has the same shape, but not necessarily similar, because the ratios are not equal. Okay, on this one, again, I'm going to see if I can make this a little bigger. So I have my two triangles. I'm going to put 6 over the corresponding side of 8 and 8 over 12. So 8 over 12 reduces down to 2/3. 6 over 8 reduces down to 3/4. Those two are not equal, so therefore it's not similar. The ratio of the two sides. Okay, the next part, there are two methods when trying to find a missing length. I personally only like one. So the other video that I have online has both methods. In this video, I'm just going to show one method. But I'll explain how to do both. I'm just going to show one, though. So method 1 is calculating the scale factor and then multiplying the corresponding side lengths of a missing side by that scale factor. Well, I don't like this way, because if I have a triangle that's 2, 4, 6, and the next one is 4, and this one's 8, I would first find the scale factor. So I would do 2 to 4 and 4 to 8. Those reduce down to what? 1/2. So 1/2 is my scale factor. And then I want to multiply my unknowns, my corresponding side to my unknown and multiply it by 6, which would get me 3. That is wrong. This is wrong because right here, if you look, 2 is multiplied by 2 to get to 4. 4 multiplied by 2 to get to 8. 6 multiplied by 2 would get me 12. So 3 can't be the correct answer. I multiplied it by the wrong thing. I was supposed to actually multiply it by my unknown here, which was, say, x, and it's going to equal the 6. And then I would actually have to solve an equation that I don't think we like to do in here. I could just multiply it by 2, right? When you have a fraction and you want to get rid of that fraction, multiply by the reciprocal, and then multiply by 2, and x is equal to 12. That's the correct way to do it. It just gets confusing on what you're supposed to multiply by, the 1 over 2 or the 2 over 1, and yeah. So the way that I like to do it is I like to set up a proportion, right, and solve a proportion that we have done in here before. You set up a proportion, you have to have 2 fractions set equal to each other. So like 1 over 2 is equal to 2 over 4. That's true. That is a proportion. And I can cross multiply to solve for any unknown sideling. So if I didn't know one of these sidelings, I could solve for it by cross multiplying. Anything with a proportion to remember, or something to remember, is these two things have to have something in common. Whether it's the same shape, from the same shape, or it's the corresponding sides. So just for doing this and staying all on the same page, we're going to do, this is the same shape, and then these are the actually corresponding sides. Sorry. Up and down in the same fraction is the corresponding sides, and this one is the same shape. Okay. So I'm looking for, and this is the start of that video now, but that's okay, I'll just do this one. I'm looking for m. So I need to set up a proportion. And it shows you how to do the first method right here. But I want to set up a proportion. And these are going to be my, what did I say? It's going to be corresponding sides. So these two have to be corresponding sides. So here, I'm looking for x, y, and that's my two middle ones, right? So I'm going to put m in there for x, y. My corresponding side to x, y, so these are my two middle ones, would be BC. So side BC goes here, which is 12. And then here, I need to find two side lengths, one from this one and one from this one. But m is from this shape, so I need to take this one from this shape. So I'm going to take 15. I'm taking it because I'm using 15 because 10 is the corresponding side, and it's there. If I were to take 24, I don't know what the corresponding side of 24 is. I haven't figured that out yet. Okay, so 10 would go here. Noticing that 12 and 10 is the same shape. M and 15, taken from the same shape. M and 12 are corresponding sides. 15 and 10, not M and 12, yeah. And 15 and 10, corresponding sides. Okay, to solve my, I'm going to rewrite it down here. Well, not so messy. So I need to cross multiply. So what's 10 times m? 10m. And 12 times 15? Is it 180? Yeah. And then I divide both sides by 10. M is equal to 18. So that's my unknown length, or M. So I'm going to skip that next one because it's just too messy. So on this one, I set up my proportion. So 3 and 6, they're these two instead of before. But so before I said these two have to be the corresponding sides, but they have to have something in common. So in this problem, I do these two are the same shape. Oh, it doesn't matter actually. So these two are the corresponding sides, and these two are the same shape, or opposite. It just works out. But anyway, so 3 to 6 is 6 to unknown here of x. So I have to cross multiply. 6 times 6 is 36. 3 times x is 3x. Divide by 3, and x is equal to 12. So this is 12. And then here, 3, I use 9 and y, and 6 and 12, and cross multiply. When you are doing this, when you get down to the answer, you can figure out, if you look, 6 is half of 12. What is 9 half of? 18. So if I were to get anything other than 18, I should look and say, okay, that doesn't make sense. Let's try check your math again. Okay. Your assignment is page, what is it, 549? 1 through 5 odd. 9, 10, 13. 17 what? Thanks.